Welcome back to the second part of Newton's 3 laws of motion. In this video we are going to be looking at some different types of application type questions of Newton's second law. And it's really going to be looking back at the similar types of questions that we had looked at in our last lesson on just the different types of force. So let's move on to example number 4. So if Jordan and Brandon hold a 400 Newton anvil aloft by lifting it straight up, what is the force that each person exerts? And here we're going to assume that they exert equal force. So here we're talking, I guess just looking at the question itself, when we're talking about holding something aloft, that just means that we're holding it in the same place. So when we're looking at, say, like our overall net force, here our net force would be equal to 0. So that means that the gravity pulling it down and then how, like Jordan and Brandon pulling it up, it's overall not changing, so it has a net force of 0. Here we're talking about when we have a 400 Newton anvil. That's just sort of as like the same sort of concept as like mass and weight. They're all not the same thing, but it's just sort of a different way to express that. So here we're just saying that there is a 400 Newton force that's pulling it down. Okay? So I'm just going to draw just a quick little sketch of this object. So here we have a really great anvil. I know that's how all anvils look. I know I'm an artist. But anyways, so here we're going to be looking at the force that's pulling down on this anvil is 400 newtons. And so if we're holding it in the same place, that means that we have a net force of 0, which means that that force that's pulling up, or that normal force, is also equal to that gravitational force, which is 400 newtons. Okay, so we can even just write this out if you like. So I'll just put a star here, so your overall net force is equal to 0 because it's being held still. So this upward force, which is our normal force, so Fn, so that is also equal to 400 newtons. So this is the total combined force that Jordan and Brandon are exerting on this anvil. So assuming that they have equal force, then that just means that we have to divide this force by 2. So therefore their force is equal to, so it'd be 400 divided by 2, which 400 divided by 2 is equal to 200. Here we're talking about our force, and so here units are newtons. And in this case here, because we know that we are talking about going straight up, we can actually include that in our units here as up. So then just to finish off this question, we can answer this with a sentence. So we can say that Jordan and Brandon each exert a force of 200 newtons up. Okay, so moving on to example number 5. So now we're going to look at the exact same two people. We're looking at Jordan and Brandon, but this time they are each lifting the anvil from a 60-degree angle from the horizontal. So here we want to know, once again, what is the force exerted by each person, assuming that they are exerting that same force. Okay, so once again, I'm just going to start by drawing a little diagram here. So here is our anvil. You know that it has that downward force of 400 newtons. And here we're going to be assuming that they are still lifting it aloft. So we know that that overall vertical or that upward force here is going to be 200 newtons each. So going from here, we have our little forward motion. So that's a really beautiful straight line. This one here should be 200 newtons each. But maybe Jordan's going to be pulling from one side and Brandon's going to be pulling from the other. And we know that this angle from the horizontal, so going horizontal going up, is 60 degrees. So here we're doing is we want to find what is the actual force that they are exerting. So we're looking for this line right here. We're looking for really, these two lines that are at an angle here. So if you're wondering how we can solve this, is that you can either see that we're starting to look like we have some right triangles being formed out here, or if we were to connect Jordan and Brandon's points here, we have two right triangles that are just kind of flipped upside down from what we have a standard drawing for a triangle. So I'm just going to do a little arrow here. So this 200 is pointing to that little leg here for that triangle. So in order to solve triangle questions, you need to have at least 2 bits of information. We have 200 here, which is this vertical piece of this triangle, and we can work with this 60 degrees. It's not inside of your triangle, but we know that if this here is a right angle that's being formed because of this beautifully perpendicular line, we know that this creates a 90-degree angle. So if this part here is 60, then this inside angle right here has to be 30 to make that perpendicular. Then we have an angle, a side, and then we just have to be looking for this part of the triangle here, which I'll label as x, which is also our hypotenuse. So we have an angle, an adjacent, and the hypotenuse. So in order to find this overall force that Jordan's pulling up on, is we're going to be using the cosine equation. So that's cosine is equal to your adjacent over your hypotenuse. Then we'll go ahead and plug in our information here. So we have cosine of 30 degrees is equal to your adjacent, which we know is 200, over your hypotenuse, which we can let be x. We can write our a cosine of 30 over 1, and we can use cross multiplication to solve. So we have x times cosine of 30 degrees is equal to 200. And then we want to get rid of this value connected with x, so we're actually going to divide both sides by cosine of 30 degrees. Gets rid of that. And so what we have is x is equal to 200 over cosine of 30. There you can go ahead and plug that into your calculator, which if you plug it into your calculator, you should get 230.9, that's rounded. But we do have to account for sig figs here. And this is kind of where this question here gets a little bit gross. Because here when we're looking at our force that, or I guess our adjacent side here, this one here has 1 sig fig. So that means that our answer also has to have 1 sig fig, meaning our answer once again is 200 newtons, which I know is probably going to make some of your brains really upset because now we have the exact same force being exerted on our anvil, which we know is not the case, especially since we had this rounded value here of the 230.9, but that is the way that sig figs work. Okay, so just to finish up that question, let's finish this off with a sentence. So we could say that the force exerted by each person is 200 newtons, and we should include our little direction here as well. We're just going to say that the direction here is up. I know that each person's really pulling it from 60 degrees from the horizontal, which if you put up or the 60 degrees from the horizontal, I would accept either or. But just for simplicity's sake, we're just going to say that they're going to be pulling it 200 newtons up. Okay, so let's move on to example number 6. So an artillery shell has a mass of 55 kilograms. The shell is fired from a gun, leaving the barrel with a velocity of 770 meters per second. The gun barrel is 1.5 meters long. Assume that the force, and thus the acceleration of the shell, is constant while the shell is in the gun barrel. We want to know what is the force on the shell while it is in the gun barrel. So here what we're looking for is we're looking for force. So to really look for force, we know that we have the equation. Your force is equal to your mass times your acceleration. In this question here, we're given the mass, which we know is 55 kilograms, but we don't know what the acceleration is, so we have to find this. And so in order to find that, we're actually going to use one of our kinematic equations that we learned in our first unit. And before I just give you which equation we're going to use, I'm just going to show us the process that we should use in order to find that. So once again, we're start by writing off all the other information that we know. We know that the gun is fired with a velocity from the barrel at 770 meters per second. This is when it's leaving the barrel, and so this tells us here that we have a final velocity of 770 meters per second. Here we have the gun barrel is 1.5 meters long, so that's the distance that it's traveling. And that's about all that we're told in the question. There is one more bit of information that we know. We know that when the shell starts out in the gun, we know that it's not moving, so we can assume that our initial velocity is 0 meters per second. So then what we want to do is we know that we have our initial velocity, our final velocity, our distance, and we're looking for our acceleration. Go back and look at your formula sheet and try and figure out which equation you're going to use. So it has to have all of this bit of information. In our kinematic section, we didn't really work with mass, so we really just want to be concerned with these 4 variables. And so if you've taken a look, you would know that that is equation number 5 from your lesson. So that equation is our final velocity or final speed squared. It's equal to your initial velocity squared plus 2 times your acceleration times that change in distance. So we're going to plug in our values here. So our final velocity here is 770, and we're going to square that value. Our initial here is 0, so we have 0 squared, plus 2 times our acceleration, which we don't know, so we'll leave that in as a, and then times that distance of 1.5. I'll just put this in brackets here. Yikes. So next what I'm going to do is I'm just going to clean this up just a little bit. So we're going to put the 770 squared into our calculator, and we should get 592,900. I'm just going to keep track of sig figs on my way here. So we have 2 sig figs and 770, which means our answer should have 2 sig figs as well. 0 squared is just 0, so we can forget about that. And then here I'll clean this up here as well. We have 2 times 1.5, which is 3, but we're at a 0.0 because of our sig figs here. We have 2 sig figs in the 1.5, so our answer here should have 2 as well. Alright, so now what we want to do is we want to get rid of, we want to get this acceleration by itself, so we're going to get rid of this 3.0, and we're going to do that by dividing. And if you plugged into your calculator, we get this massively long number. We would get 197,633.33, so on and so on, as our answer there. And once again, I'm just going to keep track of my sig figs here. So here we were dividing by 2 sig figs by 2 sig figs, so our overall answer here will have 2 sig figs. So I'm actually just running short on my little time limit here. I'm only allowed 50 minutes, so I'm actually going to finish this question in the next video.